In this video, I'm going to show you how to integrate secant squared x and integrate another function which is very, very closely related to secant squared x, which is the integration of tangent squared x. These two integration questions are different, but they are very, very closely related, as you will see in a while. So let's get started. Now, for the first question, I'm going to show you the integration of secant squared x with respect to x. And this is a very standard question. You should know the answer. When you integrate secant squared x, you get tangent x and you add the arbitrary constant. Okay, now for the second question, this is really easy. Now for the second question, we're going to integrate tangent squared x with respect to x, and tangent squared x cannot be integrated directly. So what we're going to do is we're going to use this trigonometric identity, secant squared x equals to 1 plus tangent squared x. We're going to use this identity to replace the tangent squared x with secant squared x minus 1. So we're going to take tangent squared x, we rearrange this identity to make tangent squared x the subject of the equation, and you will see that tangent squared x equals to secant squared x minus 1. And we're going to use this identity here, this rearrangement of this identity, to replace the tangent squared x, to replace the integrand. So let's get started. So we have integration of tangent squared x, and what we do is we use this identity, we replace tangent squared x with secant squared x minus 1, and that's what we do here. We remove tangent squared x, we replace with secant squared x minus 1, and now we can integrate both terms in sequence. So when we integrate secant squared x, we get tangent x. When we integrate minus 1, we get minus x, and we add the arbitrary constant c, and that's what we have. Okay, so here the lesson I'm trying to show you is this. I'm trying to tell you is this. When you do integration of trigonometric functions, a thorough knowledge of trigonometric identities is very, very important. It's really very important because sometimes you need trigonometric identities to make the integrand into a form, to transform the integrand into a form that you can integrate. This is hard, but this is easy. So here I've transformed the integrand from something that's impossible to integrate into something that I can handle. All right, so thank you for watching. See you in the next video, and if you find the video helpful, do subscribe to my YouTube channel at this particular URL. Thank you and bye bye.